Welcome to this explainer. Today, we're going to rigorously unpack the exact equations forming the bedrock of the unified Adelic architecture. Now, if you've been tracking the recent theoretical shifts in quantum transport and arithmetic geometry, you already know that bridging the gap between non-invertible symmetries and classical space-time trajectories is, well, notoriously complex. But today, we're skipping the high-level fluff. We're going to look directly at the math that actually makes this synthesis possible. Here's our roadmap for the breakdown. Phase 1 is microscopic dynamics. Phase 2 covers mesoscopic transport. Phase 3 moves into global arithmetic topology. Phase 4 tackles the unified index theorems. And we'll wrap it all up with our synthesis on the self-stabilizing loop. All right, let's just dive right into the deep end by anchoring ourselves in the core mathematical framework of this architecture. We are fundamentally looking at the foundations of Lagos field theory alongside the non-invertible Langlands program. And look, this isn't just an exercise in abstract algebra. We're going to break down the exact equations governing how an open system approach literally forces space-time and number theory to interact. To really understand this, we have to map it out from the micro to the macro level. We're essentially tracking a quantum state as it solidifies into a macroscopic classical shadow. We start off with Lindblad operators and local dissipation, transition our way through Painlevé equations, hit those global Hecke anomalies, and finally arrive at the cohomological index. So, starting things off with phase 1, microscopic dynamics. Now, before we even look at the first equation, there's a crucial concept we've got to wrap our heads around. Lagos field theory intentionally introduces dissipation into the Adelic Langlands program, which traditionally is treated as a closed system. In classical automorphic theory, operators are usually strictly self-adjoint. But here, we introduce a mass gap. We're dealing with an open quantum system where energy and information can actually be dumped out into the environment. And this non-unitary twist, it's honestly the secret engine driving this entire framework. Let's break down the variables in the anomalous Adelic jump operator, which we denote as L. The absolute heavy lifter here is that square root term sitting right at the front. That's the local arithmetic damping rate, or gamma sub m. And pay attention to how it scales. It grows incredibly fast near singular arithmetic defects, but it completely vanishes for unramified primes. Mathematically, this operator is forcing extended chaotic states to contract and relax down toward a stable vacuum. Moving on to the general entropy production equation, I really want you to focus on the exponential decay term that's driven by the spectral gap, lambda 4. The metric background here is actually acting like a one-way directional pump. It strips away non-tempered kinetic energy along the forward orientation and completely blocks it from coming back. So as time t approaches infinity, this exponential term mathematically forces the overall entropy production rate to drop down to zero. It perfectly locks the system into a stable zero entropy vacuum. Moving right along to phase 2, mesoscopic transport. Here's where things get really wild. You have to understand the stark contrast across the semi-classical time threshold, which is a strict mathematical boundary we call TQME. Before this exact epoch, the system is a complete mess. It's a chaotic, multi-channel mixing of split geodesic tracks showing this highly oscillatory power law behavior. But the second we pass TQME, those quantum fluctuations decohere. That chaotic shuffling is forced into a brilliantly clean, exponential cuspidal decay, and the trajectory finally stabilizes. When you actually compare the equations governing this transition, you see a massive shift. On one side of the boundary, we've got the highly oscillatory sign function of the Oblowitz-Segor family. But the moment you cross T sub QME, the unitary shortcut U mathematically cancels those sign components out instantly. We just snap right onto the Hastings-MacLeod tail, totally governed by that sharp exponential decay. It's not a gradual shift. It's a discrete phase transition in the state-space transport. Now, if we didn't regularize this model, that crossover would be catastrophic. It would cause a violent geometric shockwave that would just break the metric. Enter the Painlevé second differential equation. It essentially acts as a mathematical shock absorber. By mapping the distance function d of x to the transcendent q of x, the equation continuously fits the phase transition. It takes that sharp, jarring step and transforms it into a regularized, fuzzy quantum layer, forcing our classical trajectories to align smoothly without a singularity collapse. Zooming out now, we hit phase 3, global arithmetic topology. Take a second to really digest this profound concept from the text. The idea that entanglement is actively behaving as an internal quantum mechanical pressure. The vacuum isn't just empty space, right? It possesses topological long-range order. And this is not just some philosophical musings. It has a very direct, very real mathematical function acting as an absolute shield against gravitational collapse. Translating that philosophical shield into cold, hard math, this area law equation relies on the universal topological entanglement entropy, gamma top, to block infrared singularities. Notice that minus gamma top term sitting in the entanglement entropy profile S sub A. Because it's mathematically defined as the natural log of the total quantum dimension of the category, and is strictly greater than 0, it outright proves the existence of this long-range entanglement. It's the internal pressure that prevents the field configurations from just collapsing into a zero-volume point at the arithmetic boundaries. So how does this local phenomenon build into the global geometry? Well, because of our non-invertible boundary twists, the global Hecke operators failed to commute, which creates an anomaly matrix omega. In a semi-classical sense, this acts as a gravitational lens, trapping continuous bulk states. Now look at how this impacts the Arikhelov self-intersection number. See that plus gamma top sitting right inside the categorical volume correction? That non-local anomaly matrix omega actually acts as a variable that increases the geometric volume in the Arikhelov equation. We're talking about long-range quantum correlations physically boosting the geometric size of the space. Which brings us to phase 4, unified index theorems. This right here is the massive mathematical capstone of the entire framework. And this equation is just incredibly elegant, because it forces an absolute equivalence between two entirely different realms. On one side of the equivalence, we are integrating physical logos field currents with the bilance and regulator. On the other side, we're calculating pure geometric volume via the Arikhelov self-intersection, completely equipped with those topological entanglement entropy corrections we just talked about. And because that geometric side is bound tightly to an integer-valued index, it means the gravity fields are topologically quantized. It mathematically proves that classical geodesics are not just drifting around, they are rigidly locked in place by the topology of the boundary interfaces. And finally, synthesis, the self-stabilizing loop. When you step back and put it all together, the equations confirm we are looking at a perfect, self-stabilizing loop that dynamically preserves the classical shadows of the global quantum state across the entire Adel ring. Think about the journey we just took. We started at the top with quantum dissipation via Lindblad operators. That triggered painful regularization to smooth out the jarring phase transitions, which then fed into not-deformed topology and Hecke anomalies, ultimately resulting in absolute Langlands stability through global index theorems. The non-pointed categorical symmetries are physically weaving a regularized vacuum where classical spacetime paths are strictly necessary, uncollapsible shadow. So I want to leave you with this final, truly provocative thought. If space-time trajectories are merely these coherent, uncollapsible semi-classical shadows, what does that mean for gravity? It strongly implies that the very fabric of space-time might be topologically quantized by the strict rules of arithmetic. If gravity and geometric volumes are actually dictated by prime numbers and categorical fusion channels, well, the universe is far more fundamentally intertwined with pure mathematics than we ever dared to imagine. Thank you so much for joining me on this deep dive into the math today, and I really hope this explainer helped illuminate the incredible architecture at play here.